So this is going to be very informal. When I initially did this at Perf Matters, I had 27 minutes and I had so much material that I just had to start at the last minute while I was rehearsing, just start removing things because I was going over. And so right now you'll see everything that I cut on those 27 minutes. I don't know how long it's gonna be. I haven't rehearsed with additional slides, but so just bear with me, this is gonna be very informal. So, hi, I'm Alfredo, but you can call me Al. I'm a director of engineering at Hearst, like Sergio mentioned, and if you are not familiar with Hearst, it's a media company with more than 360 businesses, but its major interests include magazines, TV networks, newspapers, and more. And some of the properties that you might be familiar with include Cosmopolitan, Esquire, and Elle. But there are a lot more. In total, right now, we have 178 web properties, only on magazines. And when I initially started at the company, we had much fewer companies, so it made sense for each website to live in its own code base and allow teams to move really, really quickly. But as we kept adding more properties and we would test a feature on one side that proved successful, and we wanted to immediately roll that out across all of our properties. It was impossible because the code base would just differ so much between sites that it was impossible. So that's when we decided to put all of our properties powered by one application. That means 100+ websites powered by one application. And it's awesome because it gives us the flexibility, like I mentioned. We launch something, we launch it worldwide in one click. But it also gives us that responsibility that when we break something, we break 178 sites, just like that. And when we slow things down, we start losing money, just like that. Performance really matters for us. Because of this, we knew that that was the way to go, and having those problems were the right problems to have. Another thing why performance matters for us is because we can see that bounce rate goes up the longer that your site takes to load. Actually, at 2 seconds, the majority of people start leaving. As you can see by this pink line, how it drastically goes up. And that's just because how our brains work. After 1 second, our brains go into passive mode. That means that we feel like we're waiting. So if you're trying to, the sweet spot to start showing something to the user is around the 2-second mark. Because after that, users feel like they're waiting. And studies have proven that humans overestimate time by 36%. So even if something after 1 second, it was just another second until something showed up, to the user actually feels 36% higher than that. When we initially had this problem that our sites were really slow, we took a step back and we asked ourselves, well, where do we start? And there are common approaches out there by performance advocates, and the most common one is to get the executive buy-in. How do we convince the people that are making the decisions of where we put our time to put some time for working on performance? So I initially put a deck together to show the executives why we should be focusing on performance. And the very first thing that I did was to measure. Using web page tests, you can just start getting some metrics of how your website is loading on different devices and different speeds, 3G, 4G. I recommend to just go /simple. It's a slow 3G, and that's a really good place to start. Another recommendation is that you can block outside domains so you can compare how your website is loading without any third parties and compare them with third parties, because the main difference there is that what's the things that you can control and actually optimize versus what the stuff that you can't really control versus maybe optimize it when it loads or maybe just remove it altogether. And you can use Lighthouse on the Chrome DevTools, but also they provide a CLI where you can start getting reports right from your build. These tools are called synthetic testing. And what synthetic testing means is it's just tools that are using simulated users to provide information on uptime and the performance of critical business transactions. So they're trying to replicate as much as possible so you can actually compare apples to apples between one optimization to the other. Because if the device changes or the test environment changes, you can't really completely measure that you did something and improved something by so much %. But there's also RUM, which stands for real user monitoring. That means getting those same metrics, but from real user devices. And there's a small library out there by a friend of mine called Perfume.js, which really quickly lets you get these metrics by running this library. And you can get first paint, first contentful paint. And what I found the most important, which I'll talk about a little bit, is first input delay. But you can also hook up your Google Analytics to start reporting all of those metrics that some Google Analytics shows you some of this, but not really the breakdown as much as you can have this. And also, if you have your custom analytics or you want to put it somewhere else, you can also hook that up with Perfume.js. So what metrics should I really care? There's all of these metrics of the whole life cycle of the page. Here's a diagram of from start to finish. There's navigation start, their first contentful paint, and time to interactive at the top. And I mentioned first input delay, which is a new addition. And to me, it's the most important metric. Because unlike time to interactive, which measures how long the main thread is idle for 5 seconds, that's what time to interactive is. It checks that the main thread is not doing anything else, and that's what determines that the user can interact with your page. But first input delay actually measures the time from when a user first interacts with the site. So for example, it measures the time when a user clicked a button or clicked a drop-down, and if the browser was able to respond to that interaction, which I feel is the most valuable information that you could get, because there's something known as rage clicking, and that's when you click first, didn't work, clicked again, didn't work, and you start tapping it really, really well. And FID handles that scenario, because that anger is what causes users to not only exit, but just not come back. And after you have that information about your site, you can start comparing yourself to competitors. Using the Crux dashboard, you can start putting URLs from competitors and get what are their metrics and what are their connection distributions. So if most of your users are going on 3G and most of their users are going to 4G, maybe it's not useful for you to compare yourself to them on 3G, but rather compare yourself to the percentage of the majority of users that are going to their sites. So for example, the audience of Hacker News is vastly different to the audience of Reddit. Most people would go to Hacker News on a mobile device, while more people would go to Reddit on desktop computers. So comparing mobile to mobile is not actually the right comparison, but rather comparing where the majority of the audience is. And device distribution as well, like I mentioned, who's going more to phone or desktop. And you should be comparing to your competitors on the majority rather than apples to apples for this exercise. And there's another site, Think with Google, that lets you benchmark mobile speed index, which is just an average of all the metrics, first contentful paint, time to interactive, all of that put together, and that's what speed index is. And you can put your site, and these are actually competitors. I just anonymize in case someone hears from them, but these are actually competitors, and we're faster than them. And this is a really quick way to just take a screenshot and show that to the executives. And most importantly, they also have a performance calculator, which you can put some variables like your monthly visitors, conversion rate, and it will tell you how much money you could possibly be leaving on the table by not speeding up your site. And when I presented this deck originally to the executives, I still had some slides left after this live, but they just stopped me and say, well, let's just do it, right? Like, that's what matters to them. Like, you could tell them, well, our sites are loading in 30 seconds, but you tell them, we're losing this amount of money, they're gonna care about that. So now that we had the go-ahead from the executives to start working on performance, myself, along with a few other folks, started looking, well, where's the bottleneck, right? What is the most critical thing to start working rather than there are all these things that have little problems, but you want to start with the most impactful one. And based on our testing, we found out that JavaScript was a huge bottleneck for us. And the reason why JavaScript is a huge bottleneck is because it blocks the main thread. In browsers, everything goes through the main thread. If something blocks it, that means that scroll events, click events won't happen until whatever it's using the main thread will give it up. By the way, I did that GIF. And if we look at the HTTP archive, sites have only been getting bigger in terms of JavaScript size. And this is since HTTP archive started tracking metrics. And we can see that the median site ships an average of 350 kilobytes, which equals to 15 seconds to time to interactive. Try to picture that. That's 15 seconds that you cannot interact with the site. That's a long time. And also, notice that this is the median size. It's not the average. The average is actually 500 kilobytes, which you can see by the shadowing. If you see the shadow part, that's actually the average. And you can see that that tail grows really big very quickly. So we have to ask ourselves this question: why is JavaScript so different? Why is JavaScript so slow than, say, CSS or images or any other asset that we load? And it's because all bytes are not equal. The same kilobytes of one JavaScript file, it's not the same as the same size of an image. And the reason why is because they go through many different steps. This is a very top-level view of the steps that it takes to execute JavaScript on a page. You first download it, then it gets parsed, then it gets compiled down to C++, so the browser can understand it, and then it gets executed. And each one of these steps have their cost. Last year, it was reported that parse and compile took 10 to 30% of the time spent in Chrome during page load. That's a long time. And this was last year. Now, this year, Chrome did some improvements on that parsing cost. And they were able to start doing some chunking and some techniques to improve that parsing update since versions 70. And what they did is this technique called script streaming. And what it does is that as soon as at least 30 kilobytes start downloading, they start parsing and compiling it on a worker thread. So that means that by the time that it needs to execute, the content is right there to start executing. And since Chrome 71, they actually moved into a task-based workflow where they can do this for multiple files concurrently. So before Chrome 71, they were doing this, but they were doing it one file at a time. But now they're able to do it concurrently. And this led to 2 to 3% time to interactive improvement because the main thread becomes idle faster. So time to interactive, which is tracking the time that at least 5 seconds the main thread has been idle, is going to improve because they moved it to a worker thread. So knowing all of this, we start tracking where were we before. We had a feed bundle on our feed pages, home pages, and also section pages that was 100 kilobytes, 115 kilobytes. That's 360 kilobytes uncompressed. And this bubbled up to, on mobile 3G, it took almost 2 seconds to load. And then it started executing. And you can see the main thread activity by that pink square. This means that nothing else at this time can happen because this file is just simply using all of the main thread. Ideally, you should see this graph on very small sections spread out as much as possible. So anything in those gaps means that that's when the user can scroll, can click, or can really, anything else can happen. And this really added up to our overall load time of almost 13.5 seconds. So this was not good. So now we knew all of this. So now we can start making it faster because we have something, whatever we do, we can start comparing it. Instead of talking about all of these techniques, about like Webpack and code splitting, we took a step back and just start asking ourselves, does the user need this right now? Like, what's the value between user experience and what we're getting out of whatever we're loading? And make that comparison. If something is not giving us the conversion rate that we're expecting, how is that affecting the user experience? And that leads us to, instead of simply start deferring things by looking at the page cycle, we started inferring by user actions. And I'll give you an example of this. On our feed pages, we have what is called an infinite load feature. That means that as the users start getting to the bottom of the feed, we backfill it with more information. A usual technique is to have a scroll handler and just comparing the scroll position with the scroll position with where the user is. But a better technique is using intersection observers that lets you have a handler getting a notification when that item comes into view. So for example, here we get the middle-ish element because sometimes we have odd numbers. And then we create an intersection observer. And then we observe that little element, middle of the feed. And when that element fires, we first check, is it being intersected? And if it's not, we just return very early. But if it is, we automatically disconnect the intersection observer because we got the notification that we needed. And that's when we load the code that deals with that AJAX call that talks to the server in order to get the second page of infinite load and put it back. That means that if someone doesn't scroll down as far down, they never load this code. And then we fired a method to start doing the same technique. This module, again, sets up another intersection observer, but instead of looking at the middle of the element, it's looking at the bottom one with a threshold up. So that way, as the user starts scrolling down, they reach the middle element, we start loading this file, so by the time that they get all the way to the bottom, that file can do the AJAX request and backfill it. And we also do progressive enhancements, and this term is usually referred to the use of polyfills. So if you want to use a new cool feature on Chrome, but it's not supported on older versions or IE, you would polyfill it in order to be able to write the same code and have it work the same way. But you can also think about this on the features that you have on your site. So for example, we have a search modal that has this feature called a type ahead. When you start searching, you get some options of what you might want to search. And if we start thinking, what is the minimum set of actions that we need for the user to achieve something, is that they need to be able to open that modal and start typing and hit enter. At that point, the type ahead becomes a progressive enhancement. It's like, yeah, it's nice to have, but we shouldn't block this from the user doing that action. So we were able to split that type ahead functionality and put it on a different module. So that means that if you're on a slow connection, as you're typing, you might not see the type ahead right away, but as that module loads, then you'll get the options. We realized that to do that action of opening the modal and just let the user type and hit enter, we didn't even need JavaScript. We could do it with CSS, which is my favorite technique. And that means that we can even disable JavaScript, and the user can still do that. So in this example, I go and I'm able to disable JavaScript, and I can still open that modal. The type ahead is not going to work, but the user is still able to type and hit enter. And this tries to mimic if you're in a really slow connection, which is equivalent as pretty much not being able to load the file. And in order to do that, we take advantage of the CSS Target position. So the way that it works is that we have our icon, we give it an href to an anchor tag, and then we have our modal with that ID, and using the CSS Target position, we're able to show or hide that modal. So we have this modal, which is position fixed, and we change this Z index position to hide it and show it. But another better way of doing it is using the details element. This is all the code that you need to show that modal. And you don't need any JavaScript. And with some CSS, you are able to achieve the same way. So I have a glitch, and you can go to that URL. I'll share the deck, and you can go to that URL, and you can see the code, which is a little bit more of what is shown there. But on the left, I'm using the technique that I just talked about, the CSS Target. And on the right, I'm using the details and summary. So the URL does change on the left, and on the right, it doesn't, and I'm showing the same modal. And GitHub actually uses this for all of their modals. That's right, you need a polyfill. So the plus of the CSS Target is that it works absolutely everywhere. But for the details, you do need a polyfill if you are supporting IE11 or Edge. This is my favorite topic, web workers. Why? Because they let you put stuff out of the main thread. And as we talked about, the main thread being blocked is the worst thing that you could do. We use a little library called comlink to be able to achieve this, and it wraps all of the functionality in there so you're able to write less lines of code. And basically, it's a wrapper on web workers, and you're able to send stuff to it and communicate that way. So in this example, we're creating a new worker, and we're creating an app. And app actually lives on the worker. So when we call app do something, that's actually whatever is happening in that function is happening on a worker thread. And this is the code in the worker. We have our app, and inside we have a function where we are doing an operation, and we return that result. Now, workers are usually commonly recommended when you're doing like really expensive things, like you're creating an image, or you are rotating it, or you're doing something that is really expensive that you know that is going to block the main thread for a certain amount of time. But my recommendation is just use it for everything, because the more that you move stuff out of the main thread, the more faster your sites are going to load. And that's the huge pro of using web workers. Simply offload work from the main thread, but also a really huge pro of using web workers is that you can have as many as you want, and they don't block each other, and they also don't block the UI. So you can have multiple things going on workers, and they're not blocking the user experience. So the user is still able to scroll and start clicking, and they are just happening, and they're doing their own thing, and you just get a callback whenever they're done. But they do have one downside, that they cannot access a document. So like I said, creating an image doesn't really need to access a document. You just create an image on the fly, and you might want to do something to it, right? But if you need to access something on the document, you cannot do it in a web worker yet. And again, there are multiple libraries that do this. We use comlink. It's pretty small, and I feel personally I like it. It's really not that much code that you need to write in comparison to other libraries, but just choose a library and move to web workers. But there's one downside that a lot of people put as an excuse to not use web workers, and I want to talk about it. That they say, but postMessage is slow, right? There's all these asynchronous calls, and I can't rely on it coming back soon enough. But I'm saying no, it depends. And I'm so lucky that Surma, this Google developer, he actually wrote a great post yesterday. And he said this: even on the slowest devices, you can postMessage objects up to 100 kilobytes and stay within 100 millisecond response budget, which is what's recommended in order to make the user feel like the experience is snappy. And if you have JS-driven animations, up to 10 kilobytes are risk-free, meaning that they're not going to feel like they're lagging. My recommendation is, if you are using JavaScript animations, try to do as much as possible on CSS, because you take advantage of the hardware acceleration of the device. And also, browsers have a compositor thread. That means that once a CSS animation performs, it gets cached into the compositor thread. And you can do a test that if you run an infinite loop with a CSS animation, everything else stops, but the CSS animation will continue playing on the browser. Like, you won't be able to scroll down or click, but you'll see the CSS animation still going, because it gets cached into this compositor thread that is obviously a different thread than the main thread. But it's really good to know this, because you can do a lot of stuff on 100 kilobytes. there's the source. He goes really deep on how postMessage works and the cost with it. And mostly for animations, 10 kilobytes might not be enough. So that's my recommendation. Do as much as you can with CSS and then backfill it with some JS. But like I mentioned, one of the downsides is that you can't access a document. But now there's a worker DOM library that is in alpha mode and lets you do exactly that. It's very early, but right now it has a two-part. It has an index.js that creates this main thread object, and then a worker that takes care of the pretty much what comlink does. So once you load the first part of the library, you're able to access that main thread element, and you can upgrade an element. In this case, we're getting that the element app script, and you can see that they do this sort of like hacky that the element has a source, simply so we can get that reference to that file. Right? So obviously, app.js is not going to load because it's just in this random attribute called source on a section tag. But we just need to get a reference of what file to load. And so you pass that to the main thread upgrade function, and you pass the second part of the library, which is the worker. In the worker, you are able to start creating elements and appending them to the document. And you can start creating input listeners and start changing stuff. So in this example, I'm creating a p tag with an input, and as you start typing, if you type change, it triggers a toggle function that changes the color between green and red. And this is how it works. And this is a very simple example, but all of this is happening on a worker thread. None of this is happening on the main thread, which is mind-blowing. So I would say if you have something very critical, like maybe we're starting using it for a leaderboard. So it's the third party that we have that is also happen to be on the most visible top part of our pages. So we start using this simply for the leaderboard. So that way we can get the best experience out of that. And everything else still goes through the main thread. And after doing all this sort of stuff across all of our pages, this is how we fared after. Our homepage bundle went down to 9.4 kilobytes. That's 27 kilobytes uncompressed. And if you remember, now with the script streaming, 30 kilobytes is when Chrome now starts doing their optimizations. So they recommend for your bundles to be between 30 kilobytes and 50 kilobytes to take advantage of that feature. But obviously, anything smaller, it's going to be better. But you do want to take advantage of that Chrome feature, while at the same time, other browsers like Safari to not be as slow. So the sweet spot is really to be between 30 kilobytes and 50 kilobytes. And that's a really good number to have as you start doing code splitting, and people go really wild of just splitting everything, and you have tiny modules, which also has a cost, because HTTP 2 loads everything concurrently, but it has a limit. After, I believe, 6 or 7 parallel connections, it starts slowing down. So you do want to split things and load them concurrently, just not absolutely everything. So that's a good spot to know between 30 and kilobytes to have splitting modules. And this added up to loading our module on 220 milliseconds. And you can see now the main thread activity is nice. It's small blocks really sparsed away. So all of this white space in between, that's amazing because anything can happen here. Images are loading, the user scrolling, anything is happening. And this bubbled up to our pages loaded on that time that I talked about bounce rate, 2.5 seconds. That's the sweet spot. That's when people start feeling like they're waiting and they're going to leave. That's when you start wanting to show them something. To put that into context, that's on average 4 seconds faster first contentful pane. So this is a video of how we were loading before. On 6.5 seconds, we start seeing something. And then 13.8, we're done. And this is how we were after. We start showing something at around like 1.5, I think. And doing these optimizations were great because we were able to start now feeling that importance of what's showing up first. So we were able to see like that pink rectangle showed up first, which has no value to the user to just see a pink rectangle on a white page. So we were able to do really quick optimizations for perceived performance. We added a little background with a CSS animation, so we can get that. We can give that feeling to the user that, hey, something's happening and something is coming. But the problem here is that we started making the difference between page load performance versus runtime performance. Page load performance is, I'm not interacting with the page at all. I just hit enter, and how fast can you show me a complete page, right? And runtime performance is, okay, I'm start interacting with it. How fast can you respond to me? And we obviously made our page load performance amazing, but our runtime performance was still pretty bad. And people were asking, I thought that you made the site faster. Why is it still slow? Because for most people, performance is everything. It's just one thing. There's no split. It's everything should be fast when you tell me that you improve performance, right? So the executives were asking us, why is it still slow? Why is the site still slow? And to talk about that, we need to talk about first party and third party. This is the waterfall of that 2.5 seconds. And I color-coded the different things. So at the top, we have 11 requests, which are ours. That's first party. That includes our JavaScript bundles, our CSS bundle, and the fonts. Then the tag manager comes at the 7th request, and then it requests our third party for a grand total of 125 requests. And besides of the large amount of this request, or whatever they might be doing, the main problem about this is that we're not able to know exactly what they are or where they're coming from. Third-party programmatic ads or video bidders, they're all random. They just happen to come from a different domain. You happen to get a different ad. So you don't really know where these files are coming from in order to optimize them, or in order to add a preload tag. So by the time that they execute or download, they're faster. So when they were asking us, why is the site still slow? That's really the answer to that. And this is when it felt that optimizing performance is like going to the dentist. And the reason why I think about it is because everyone is going to tell you, well, yeah, our site needs to be faster. But then no one's going to want to prioritize that. Everyone's just, everyone would agree that it's very important to go to the dentist, but no one likes going to the dentist. And it's the same deal with performance. And to keep the analogy going, it doesn't matter how many times you go to the dentist or how many times you brush or floss or use mouthwash. Nothing is going to change if you keep eating candy. And for us, third party was our candy. It's where our revenue is coming from. So people just like throw more to it because it's paying the bills, right? And we couldn't simply just remove it or defer it because our main selling point to work on performance to our executives was we're gonna make more money, right? We show you the performance calculator. So we couldn't just start removing the very same things that give us money. At this point, we took a step back and we're like, okay, we can't just remove these tags. So how can we work around them? And web workers is one thing, but again, because we don't know what these script tags are doing, we can't just put them on a web worker because they might be accessing the document, right? And if we just put them on a web worker, they won't work. So we have this idea that we've been working on, and we call it a serverless proxy. And the way that it works is that we have a Lambda function that calls our pages with a parameter called third parties that loads everything from the tag manager, and everything comes as normal. Then it groups anything that we tell it is a third party by process of subtraction using Puppeteer. We give it the list of what is ours, and everything else is by definition third party. And we upload it to an S3 bucket. All of the third parties that load it, we just get them and upload them to S3. And at the same time, we save them all of those references to Redis, to what were all the files that loaded with the URL article/1, for example. And that lets us do that when the user goes to the actual page without that query parameter. We get Redis, what are all the third parties that are associated with this URL, and we load them from our domains. That means that, sure, they're still doing whatever horrible thing they're doing, but we don't pay the price of opening connections to all of these different domains. They all load from our domain. That means that we can add a preload tag, a pre-connect tag to our CDN, so we do that handshake transaction once, and all of the files load automatically. And because we already know them, we can have a sense of what third-party partners are more important, and we add a preload tag just for those. Not for everything, but just for those. And this opens a whole different types of optimizations, right? Using Babel, we can start reading what's in those files. So we would be able to do a query for, let's say, document.querySelector or document.getElementsById. And if those are not in the file, we know that they're not accessing the document. So that means that we can put them on the web worker. And we can start doing all of this other type of crazy optimizations because we have them, and we're able to read them, and we're able to say, this script tag is doing an eval, which is horrible. So we can reach out to them and be like, don't do that, that's really bad. And now you can start doing that. And so then after that we do that, either on content invalidation when the page actually changed, or just at a scheduled time like every hour or every 3 hours where we know that we might get new ads, we invalidate and we call the Lambda function again, so it does the whole thing again. Goes, gets the page, gets all the third-party files, replace them on that S3 bucket, and replace them on Redis. And this is very early, but we're seeing like some nice improvements for this. So looking back on this time, we really focused on delivering results with that 2.5 seconds. We really went heads down and just got stuff done. But the problem was that the teams felt disconnected from the purpose. They felt like, OK, we're working on this stuff, but why? What's the overall goal of these improvements? And they kept asking, well, how fast is fast enough, right? Like we did 2.5 seconds of page load. Are we done? And the thing is that that's the problem with performance. It's seen as bug fixing. It's seen as something that you just fix and it's done. But if you start thinking in terms of using performance as feature development, of saying, we see that most of our users are coming from iPhone devices or really like high-end devices, and the people from really slow older devices and slow devices are not really on our analytics. There's a reason why, because the pages are loading really slow on those devices. So if you think of performance as a feature, as a business incentive, meaning that you can go and you can get those users and get them into your field. So this is the second part when we moved after that of the second most talked about performance path, which is focusing on developers. How can you include performance right on your development lifecycle, right? And it's pretty easy, right? Like you just need to teach and learn just a couple of 100,000 things about how to make your sites fast, not big deal. And so we decided to divide and conquer. We split performance in 3 major areas. Server performance, anything that deals with server and API calls. Application performance, which is JavaScript, CSS, and anything that is happening on the page. And development performance, which is how easy it is to write fast code. And also our build speeds and CI speeds and all this tooling that can help developers know that they're writing slow code and how they can be proactive about it. And each one of these areas have potential bottlenecks, right? Like you could add something that makes your API query be so much longer if you do a bunch of inquiries, a bunch of joins, and right? And you can add a large JavaScript and the application performance is going to be bad, or you can add something to your build that is going to take so much more seconds. So each area has bottlenecks. And I just wanted to walk you through an example. This is a document put by Paul Irish of everything in JavaScript that triggers layout. That means that if you're not familiar with the event loop has 3 steps, or 4 steps, I believe, that goes and sees what changed on the page and paints it again. Right? And that's a cost that needs to do every single time that you scroll down or anything visually changes on the page. When you access one of these elements, you are telling the browser, stop whatever you're doing and go back to those render steps, because I need you to update whatever I see on the page in order to get dimensions of something, or I want to change the styles of something, right? So when you start learning this stuff and you start bringing it into your teams, it can be pretty overwhelming doing code reviews, because you can tell them, don't do that, don't do that, don't do that, that's bad, that's bad. So it becomes really like frustrating, like, is there something that I can do? And the better question that I found, instead of demonizing these properties of saying they're bad, they're making everything slow, is asking the developers, what are you trying to do? Right? Like, go back to the feature. What is the intention of the feature? Because that lets you go back and be smart about how you use these methods that are really valuable. But obviously, if you use them in a reckless way, they can be really bad for performance. And I wanted to talk about how you can start abstracting these frequent optimizations. And I wanted to talk about get bounding client rect, which is in the list, right? So this can be really bad for performance, because what it does, it gives you the top left and bottom right position of an element wherever it's on the page. So regardless if it has position absolute or relative or fixed, it gives you from the top, bottom, left, right position where it's on the page. And it's the most precise versus offset Y or the other alternatives. It's the most precise. But in order to do that, it needs to tell the browser to stop and go back to the render step. So it's a really expensive method. There is a way to get around it. You can use request animation frame, which is the last step of the render steps, meaning that the browser first paints whatever new updates happen on the page, and then request animation frame is like a notification system of tell me whatever the browser is doing after it painted on the page. So you can use request animation frame in order to sort of be notified about the last update of that element. But there's a problem that if you have another request animation frame that is changing the dimensions of that very same element, then you ended up paying the same cost, because the browser now lost the last dimension. So it needs to go back to the render steps, because the last dimensions that you got are now outdated. So you end up basically on the same problem. And you could have this on different files, right? So it's really hard to know when one is coming first or the other one's coming later. But a better way is using the same intersection observer that I talked about. When I was working on the other feature, I noticed that the entries on the intersection observer has all of these properties, and one of them is the bounding client rect. It has this information already. And knowing this, we're able to write our own get bounding client rect. But the only difference is that it doesn't block the main thread. It doesn't force the browser to go back to the render steps. It's asynchronous. It's like be asked to notified about the next time that there's an update. We are creating this intersection observer on the fly, getting those metrics and disconnecting ourselves. And being able to do this, you keep the same API to your developers. They're still writing get bounding client rect, but they're getting this sweet optimization behind the scenes. So they don't need to know any of this. Another really simple, but really, really smart optimization that we did, we just changed all of our clicks to touch start on mobile. Developers keep typing add event listener click, but we automatically just switch them to touch start. And it makes about 100 millisecond difference experience when you're on mobile and you really quickly tap things. It feels faster. And I mentioned 100 milliseconds, and that was one of the things that developers kept asking. Is it worth it? Like 100 millisecond difference? And so we start putting some rules in place of when should performance block a PR, meaning that we should address this rather than we can figure it out later. And the questions that we ask ourselves is it part of the critical path? And the critical path is this code rendering while the page is still loading? If the answer is yes, you should optimize it, because that's like the word says, it's the critical path. Means that if you make everything gets pushed, that's how much time you're adding of the user being able to get a full render page. So it's very critical to be as fast as possible on that initial load. Another question is, how frequent will this run? Do you have a loop that you're getting data from somewhere? If you don't know that that data could possibly be 100 items and you are doing a very unoptimized loop, that's bad because you don't know how big that data could be. So you should optimize it as much as possible. Another example is interactive elements like a date picker. Users would use date pickers like maniacs, right? Like if you go to like Priceline or you go to a travel line and you're trying to get book a flight, you're like, actually, I want to go on Thursday or no, Friday. I want to see if it's cheaper. And so you interact with these elements really quickly, right? So if you don't make them as fast as possible, the user's going to get that bad feeling, of like, oh, I get frustrated, clicking doesn't work. So it's really important that interactive elements are as fast as possible. And the threshold is that they should respond within 50 to 60 milliseconds in order to feel snappy. But the biggest question is it a share or a base component? And this is the trickiest question because it's not measurable. Like everything else is like, how many milliseconds did it take, right? And the reason why this is important as a mentality is because developers get so focused on what they're building right now. I'm building this feature, I'm just looking at this right now. I'm not really thinking, how could this be used for something else? And development at that point becomes a game of telephone, right? So you're writing this feature. You write this code for this specific feature, and then you merged it, it's live, you forgot about it. Someone else comes, and it's like, this thing here does exactly what I need to do. So I'm just going to copy it and put it over here. And then if you would be there, you were like, well, actually, this was done this way because of this specific requirement. It could actually be done faster or in a different way. But now that developer just copied it, and now it's on a different part. So it just spreads, right? And I like to compare it to a game telephone. You just need one person to screw it up a little bit, and it becomes a whole different thing by the end of the last person. So what you're thinking as one-offs of like, yes, this code is kind of crappy, but it needs to be this way because of A or B or C, that becomes a pattern to someone else because they see it that is on the master branch, meaning that this must be the best perfect code that someone's ever written because it must have passed all the reviews, right? So they just use it as like the truth, as this is good to go. So looking back on this time, developers were challenged by constraints, which was both good and bad, right? Some developers really enjoy like, how can I do this with less code, or how can I do this faster? And other developers were just like, oh, come on, I just want to get this stuff done, right? Or I want to make sure that I can meet my quarterly goals of like building a big feature. And features simply took longer to finish because we would stop the PR and be like, you got to address that, man. You can't merge this thing. And education without immediate action was quickly forgotten. I kept talking to people about like, don't use get bounding client rec from document, use this function. But if they wouldn't use on the feature that they were building, if they had to use get bounding client rec a month later, they just forgot about it. They're like, oh, wait, what? And so whatever was being told to them had to have immediate action in order to be remembered. And the thing about all of these points is that each one of them can be fixable. Developers that enjoy the aspect of doing more with less, we could focus hiring on that point, right? Like just get people that enjoy that part of the job. We can make the case to the business that sure, features take longer to finish, but they're safer, they're faster. And also we can train a lot of our developers, send them to conferences, get them really trained up, and have this constant reminder of this is the way that you build things, right? So at this point, I felt like, well, is my job done? Like, what else do I do? And this is when I moved into, when I saw the bigger problem that we have, is that we were just planning for today's problem. And when we do that, we don't really think ahead. And so I asked ourselves, how can we build something today that is not blocking ourselves tomorrow? That we build something and then the next month we're like, actually we want to do something else, but we wrote it such a very like boxed way that we're unable to move away from whatever patterns that we determined to ourselves. So I started thinking of a third path of product and design. And so this is our life cycle at Hearst. someone has an idea, a product, an engineer, whoever. We moved into a prototype phase. And then we test that prototype to see, are people liking this? And if it is, then it goes into full-fledged development, into a team. It goes through an agile process, so they get estimated and they get put through the pipeline. And then we have an MVP. What is the minimum thing that this feature needs to do? And then we optimize. This is how we were doing it before. And in most companies, this is when performance happens, right? It's just seen as bug fixing. If it's not broken, if it's not slow, it's not a problem. And then coming in, I thought this is where we think performance should happen, right? Because anything before that is not real. It's just testing and just people trying this stuff out. Once it goes into the actual feature development, that's when we were trying to make it as fast as possible. But then I realized this is where it should happen, because this is when we're making all of those assumptions of what the feature should behave, what it should do. And also, we have this problem that we would build prototypes so fast and so bad. They were successful because it was a cool idea. So regardless if it was really slow or bad, people were loving it. And then once it went through the pipeline and we had to build it the right way, it just took forever. So to executives, it felt like, I just saw it live. Why are you telling me that I can't have this for like a month? And so we start getting that feedback of like, why is this taking so long? And the question that I start asking at this idea level is just asking this crazy idea. What if we're thinking right now, what if it rocks? What if it becomes the main revenue of the whole corporation, right? Like, where do you see, as a product person, if you have the idea, how do you see this thing growing? Because everyone has the vision of, if this is successful, well, I could do this, and then we could do that, and then we could do that. If we start talking about that, developers are able to react and make some small decisions, like putting a function in a different file. Those decisions that could take you a minute can make a really big difference in the long run. And asking this question allows us to design performance paths. We ask ourselves, why are we doing this? Are we doing this for the user? Are we doing this for a KPI with a partner? What is the goal of this? And once we know the goal, we can align best practices. So we're able to divide render versus runtime performance. So a goal could be, we want users to stick around longer. So we can focus on runtime performance wherever we're building, and we're able to maybe have the trade-off on rendering of knowing, sure, this is going to be a little bit slow to load on the beginning, but we're really making it faster so users, once it loads, it really performs really fast after. And we're able to divide versus mobile versus desktops, right? So desktop computers have way more resources. So if we want to build something fast, we can say, let's build it on desktop first. So that way we don't pay the penalty of slowing everything down. And we're able to just get a feeling of like, are users really liking this? And if they do, then we can start moving it into mobile. Following this also lets us document our trade-offs, right? Because we're making trade-offs from the beginning. And we're able to specify the reasons. Why are we making these trade-offs? Is it by design? We're saying, as a company, we're deciding we're not following this route. That might change, but there's documentation that at some point in time, we decided we do not want the users to do this. Or it could be a technical limitation, right? Like worker DOM, for example, it's alpha. So you might want to really take advantage of that, but it's not there yet. So you could just list it and say, when this goes out of alpha, use it. So it's really easy to just go back to a document and be like, hey guys, just do a search for worker DOM, and anything that shows up, let's fix it. And now that you have documents, you can plan them. You can describe the scenario a trade-off would block, and this is amazing for product people because they look at that, they can align that as a vision, right? So product people really hate if you tell them, hey, this is not going to happen. This building it the right way is going to take a month, and they get so bummed down. Well, how can we make that faster? And you're like, well, we can forego this, but if you ever want to do this thing, it's going to take so much longer then. So you start making those connections of the paths that you're making the trade-offs. So if they're saying, well, can we remove this button? Yes, but if you want to put it there after, it's going to be so much worse. you start making those trade-offs and really making those decisions early on. And doing that really prevents told you so moments with coworkers. That 6 months you can go back and be like, I told you so, right? And then, people don't like that. And so if you start having those conversations really early, there are no feelings hurt because we talked about it. We made those decisions. We could have been wrong, but at least we thought about it and we talked about it. So after all of this, how do we stay fast, right? So you go and do all of these optimizations, and now you want to maintain that. And they're performance budgets, right? And they're great, but it's rarely a single pull request. And this is one of my main frustration with the state of performance tools, is that they all focus about your monitoring of production or stage. And the problem for me is that is what causes a reactive culture, that after a pull request is merged, people forget about it. And then you show them that, hey, this affected the production side, we need to fix it. Then it's like, oh, well, now we need to go into fixing mode, right? So how can we get this at the very beginning, before it is even live, and knowing what the performance impact is going to be? And the problem is also that I talk to teams a lot, and the goals I feel like we're having as an industry is, how can we move faster but safer, right? Everyone's thinking we need to have CI, CD. We need to be able to merge a pull request and just go straight live, right? Like, let's just get rid of staging. Like, the perfect scenario that you talk to people is, I just want to merge a PR and it's live, right? So that means that all of your testing needs to happen on the PR, because you need to feel safer about merging this thing that just goes live. And what's happening is that the more that you invest into that scenario, that all of these people are working independently, it's really hard to know how all of this stuff together is going to look. Because what was happening to us, a developer would add 3 kilobytes, and they would be like, it's fine, it's just 3 kilobytes, it's passing the performance budget on the pull request, and then 50 of those gets merged in one day. And by the end of the day, we blew our budget. And then it's really hard to go back to them and be like, hey guys, now whose fault is it? Because each one contributed a little bit to it, right? So who's fixing it? And everyone's like, I'm not Ed. And so it becomes reactive, because it's like, now who's Ed and who fixes it? And they already moved on to work on the next feature, right? So it becomes like crazy. So I had this idea based on a tool that I built originally just for a very quick thing that we had. And it's called Spotter. And originally what it did was something very simple. It tracks the similar files open on different pull requests. So if you're modifying infinite load, and another person on a different part of the company is also modifying infinite load, it would just put that information on both of your PRs. So you know that there's another person working on that exact same file. And the problem that we had is that whoever goes first makes the other person has to rebase and work on those conflicts. And the worst case scenario was when someone was removing a function that another person was relying on. So then it's not a simple thing of, oh, I'm just fix the conflicts. Sure, it's like, now my thing doesn't work because you like changed how it works, or like removed it altogether. So that was really bad for us, because we would get to the point that we call something done, but then someone had to rebase, and it's like, I'm gonna need like a few more days on this. And so it was really hard for us to call something done. So I built this a year ago. I am going to open source it. I just need some time to work on it. Having this tool made me think, how can I apply this to performance? And this is the idea that I have that I'm planning to build after this, called Spotter CI. And what it does, daily on a given time, for us will be daily, but you could say weekly or yearly, it collects all open PRs, and you can even give it a label, say ready to merge. So we have these 3 PRs that are ready to merge. And what it does, it would merge them into a temporary branch and open a PR with some users that you have given them into a configuration. And GitHub supports groups, so you could say tech leads and put them all in one group, and that's the user that a spotter would assign the PR to it. And so let's say at 8 a.m. or 9 a.m. when you get into work, you would get a nice report of saying, if all of these PRs that are ready to merge would get merged today, this is how much more your website would be loading. So that way you're able to be proactive about it and go back to people and look at the PRs and be like, yeah, this could be faster. And go to the developer and say, hey, you could make this a little bit faster this way, or you could do this, or you could take advantage of this before it gets merged. So it doesn't feel as I need to go back to code that I thought it was done. So this is something that I'm planning to merge, but I'm planning to build, and I started building on it, but then I found a problem. I need a way to have a consolidated report of performance in a PR, so that way I'm able to get one single notification on my email about, yes, the performance, if all of these PRs are merged, it's gonna be this, right? So like Lighthouse scores or first contentful paint. And I noticed that there were no tools that were doing this. They all have similar problems. They were very focused, performance tools, I don't know why, they're very focused on single URL. It's always the homepage. And I'm like, for most properties, the homepage is never really the biggest thing. It's always a dynamic route, the most important page. And all of these tools, they were like, oh, it's just an NPM package. You just put it on your build tool and it runs and it gives you the performance, Lighthouse scores or whatever. But that means that when you run that, it blocks the build process, right? Like however long it takes to run a Lighthouse scores, that's how much longer your overall build takes. And if it fails, sometimes on early stages of development, it's kind of like a negative flag, because as you start working on a new feature, your biggest thing is just give me the URL preview. I just want to start playing with my thing or send it to the product person. I don't want you to tell me that the build failed because I know that it's not as fast as it could be, right? So developers have to continuously going into a build dashboard or diving into the logs of being like, what's wrong with this thing? Oh, it's just a performance thing. Oh, it's fine. It did build the URL, so I can worry about this later. And doing that all over the place creates that negative feeling of like, I just don't want to check the logs. Like, it's just so much work. And also, like I mentioned, there's no consolidated report. So just give me everything that is wrong with the URLs in one place so I can just look at it. So today, I'm happy to introduce a new tool that I built. And it's open source, and it's called Lightkeeper. And what it does, it lets you maintain Lighthouse budgets in pull request URLs. And this is how it works. It listens for your build CI to be completed and successful. So for example, here I'm using site now, and I listen for that to be completed, which creates a pull request URL, and Lightkeeper starts as soon as that's done, and it triggers test for a bunch of URLs. And it could fail or it could pass. And it works with all of these providers and really any GitHub check run, deployment, or status. And it has a really flexible configuration. So you can have a base URL. It has 3 required properties: base URL, a CI, the name of your application of your CI that is running on GitHub, and what type of application is. And the reason why I needed the type is because you could have multiple check runs that are running separate things. So for example, with Circle CI, you can have one that creates the pull request URL, another one that is running integration tests, another one that is running mobile tests, right? But you just want to get notified about one. And so this is how you are able to get notified just by the task that is running the pull request, that is creating the pull request URL. And you can have settings, the scores of Lighthouse. Something that was launched this year's in Google I/O, Light Wallet budgets that lets you have resource sizes and resource counts. So you're able to say my budget for scripts for this page is 300 kilobytes. Anything else, let me know about it. The same for resource counts of third party. And you have an array of routes that can be either a string or an object that you can modify all of those settings per URL. And you can extend them. This is a custom one. You can customize everything, right? So in this example, you have some settings with PWA. And you also have share settings. So we have a share settings for galleries that is extending my default setting but it's modifying the threshold of PWA to 20% of the target, and it's actually modifying the lighthouse. So instead of running it on mobile, it runs it on desktop, and it passes some extra headers to the page that lighthouse is testing. So if you want to do like how it loads with third party versus without third party, you can pass a custom header that your page is listening for to render third parties or not render third parties and get that different test. And if we look at the routes, we have a straightforward article one, then we have a gallery one that is extending the galleries, and then we have a gallery two that is extending galleries, but it's making a slight modification to the target of PWA to move it down a little bit to 80. And this is really what we need as a performance budget. We need that flexibility because web pages are not created equal. Each one has different goals. Your article page has different goals than your gallery page, and they need to be able to be reflected. We cannot, the ideal goal is to have an overall budget, general budget, that all your pages should have this lighthouse score, but that's not the deal because performance is about trade-offs. If you are loading something that is making the page slower, but it's giving you revenue, that's a business value. And this is what it does. It puts a consolidated report using the details drop down, so you can really go deep as much as you want, and you're able to see what failed and what didn't right from one view. It also has warnings, so you're able to stay on top of something that might eventually pass the budget if you're getting like you're just narrowing passing the budget. And this is how it looks with Light Wallet. You are able to see the size of the script, images, third party, and total, and the request count. So in here, we are over budget by 29 requests on what we got 79 requests. And this is the comment that it adds on the PR. Again, it's consolidated, and if you notice, it doesn't include the stuff that passed. Because to developers is, just let me know of the stuff that is wrong with my code. Everything else by subtraction, I assume that is good. So I just don't need to see it every single time. So if you do not have anything wrong with your PR, it doesn't even add a comment. If you already have a comment with issues, that's when it goes and updates it and says, okay, you had issues before, but now you're good. But if to begin with, you didn't have any issues, it just doesn't even add a comment. Because pull requests can get really overwhelming with reviews by other people, tools are adding comments. It just gets really hard to browse and be like, what's happening here? So I really focus on making the comment really consolidated so it's not occupying as much space and just give you the relevant information that matters to the developer. And another thing that I did is that if you are making improvements, it's open by default because that's the key thing for developers of being like, how can you connect them to that purpose of being like, whatever you did is making a difference, it's making the site faster, and it's right there for you to see how you're contributing to that effort. And you can make this, maybe connect this to quarterly goals of saying, hey, let's see how many things you optimized this quarter, and that would be part of your performance goals. But there's a problem with the default way that the app works, is that it only works when the build finishes, right? But you could have a really complex setup that is doing a lot of things within, that it takes a really long time to finish, but building the pull request URL is just one of those parts. So to fix that, I created a Lightkeeper bot that lets you run manually that report, but the big difference with the other tools is that this doesn't block the build. It triggers an event, and then it just keeps going. And if you want, there's the link for the full docs, but this is how it works. So this is an example of a Travis setup. It has 3 stages. The first one is that it's building the pull request, right? So it's installing all of our NPM packages. Then when it's sleeping, let's imagine that that's the code that is doing all of the pull request creation, be that a Docker image or whatever. And after success, that's when you create your URL. And that's when you would trigger the Lightkeeper bot. This will trigger right after, without waiting for the Lighthouse test to run. And this is enabled by having lambdas, because you are able to change the invocation event to. You can change the invocation to be an event, and you don't have to wait for it. It's amazing. And then we have the other stages: UI tests, integration test that could take a really long time. So this is how it works. So I'm creating the Travis, right? So if I go to the dashboard, I see that it has all these stages. So I'm going to the building pull request. It's doing its thing. It's installing npm. Right now it's taking 6 seconds to build a URL. It runs Lightkeeper bot, and right away we see continue without waiting for a response. And we see that Lightkeeper started. So that means that your build is not blocked, and Lightkeeper is going. So now I can go back and see that, sure, this finished, but it's still going through unit tests and integration, right? All of the other stuff. And the time that it took me to check, Lightkeeper is done. And this is really, really important because you are able to get on top of like, oh, I get that really quick notification that I'm making stuff slower. So by the time that the build is finishing, I can switch back to the code and start addressing it without waiting until all of this thing is finishing in order to run the performance test. And this is the general demo. So I'm on a branch that has no problems, right? Everything is good. It didn't add a comment. So I see that this is great. Everything is hitting 100%. So now I go and do something that I regret a lot, and that is really hard when you actually want to do it, which is, how do I make something slow? So I just added a ton of iframes. And this speaks a lot about Gatsby and the quality. I needed to add like 10 iframes in order to make it slow. So now I push that. So now it's updating the URL, and now Lightkeeper gets that notification, and it failed. And that's when I get that comment. Only with the error on that single URL, with only the scores that dropped. Everything else is in the full report. So now what I do, let's say that I agree to that performance drip because ABC. I'm able to go there, change that route, which is called Hi Folks, and do some custom settings. So I'm able to copy the globals. I'm adding extents, so that way I don't need to simply copy-paste everything. And I only change the properties that I care about. So I switch it to 90. So I push that. And now we go again. Now it's going to update that pull request URL. And Lightkeeper is going to run. And now it passed. And so when I go check it out, I'm able to see that now I'm actually making it faster simply because I brought the budget down, right? So my target now is 90, and the scores was 97, and the other ones remain intact. That means that, sure, if I'm making the gallery page for whatever reason we need to improve the revenue, I can take the lower score there, but I still keep all of my other pages intact. That's the link. I'll share the deck, but that's the short link if you want. It'll take you to the GitHub page, and it's a GitHub app, so you can just install it. And why am I doing all of this? Because this is what I believe, that performance culture is really more than code. It's really, you can have a slow side, or you can have a fast side, and you can still have performance culture, because it's not about fast or slow, but the choices that you're making of going and experiment and tackling priorities, but having that clear path back of, sure, let's put a third party because it's going to give us some money. But the moment that it stops giving us the money that we want in order to make the sacrifice of how much slower the sites are taking, we know how to remove it and go back to the score that we had before. That's it. Thanks for listening. That's the link for this presentation. And that's my Twitter if you want to hear more about Lightkeeper or Spotter CI. Follow me on Twitter. And thank you so much. That was long, but that's everything.
Any questions? We have a throwable microphone, the magical microphone.
So you mentioned that you have, I don't know, 200 plus properties, and it's one app. So all of them, I assume all of them, you run that in one monorepo?
Yes.
Okay. How are you monitoring performance for all apps? I mean, since it's like the same code base, it's the same, it's probably close performance, but every app has a different theme and different structure. So
Yes.
are you monitoring all these apps, or how does it go? And like, tell me more about like your day-to-day, like how you look at that data, if you do.
Yeah, so we are not focusing on properties, but rather on features, right? So a feature could be multiple sites, or it could be on only one because it's a very specific feature to, for example, car and driver has those features where you like zoom in into the car and you can like look around. No other site has that specific feature because, on Cosmopolitan, you're not gonna zoom in into a shoe, right? And so car and driver had that specific feature, so we have a URL that has that feature on the test that no other URL on other properties are gonna test. So we really, the way that we add URLs to test is this a different feature, and that's how we organize our performance.
How you doing? My name's Sam. You were saying that where you found the bottleneck, that JavaScript blocks the main thread. Could that also be a CORS issue? And how using the web workers, like the web workers, are they only for offline, or can they also be rendered like when users don't have connection to the internet?
Sure. So there's different types of worker. There's service workers, which are what allows you to have that offline PWA functionality. Web workers are not a separate thing. So they still rely on online functionality. You can put a web worker on a service worker and take advantage of that functionality. The purpose of a web worker is to offload whatever you're running from outside of the main thread. So a service worker, it's a different thing, but it's also really valuable to cache that on the browser. So if the user loads connectivity, it can still load.
I have one last question. It took a while. Do you think you're done, or you will keep working in performance? I mean, when is it over, this fight?
So this is I think I did talk about it. It's like, it's not about being done. It's about creating the right problems, right? So whenever we make something, so now we have this slide keeper tool that we're trying. I'm sure that it's gonna create different problems, but it's the right problems to have. And that's really what we're trying to get, of creating problems that we might not have, but we know that this is solving something that we need to solve, and we know that it's gonna create other problems. So regardless of what you do, you're gonna create new problems, but that's the path, that's the evolution of, you wanna go into the situation where you create the right problems, right? So like I mentioned with the serverless proxy thing, then we're getting into lambdas and how all of that works, and invalidation, right? And it's like hard problems, but the goal, if we focus about what is the goal and where's the intention coming, that's the right solution of tackling that, because we can't simply just remove third-party tags. So we know that it's the right approach, and these are the right problems to have.
Thank you.